how to determine the velocity and acceleration of a piston for a particular position of crank in a reciprocating engine analytically. Let us discuss with the problem. So this is the problem statement. The crank and connecting rod of a steam engine are 0.3 meter and 1.5 meter in length. The crank rotates at 180 rpm clockwise. Determine the velocity and acceleration of the piston when the crank is at 40 degree from the inner dead center position. The data given in the problem are length of the crank, that is denoted by the letter small r, that is 0.3 meter, length of the connecting rod, that is small l, 1.5 meter, engine speed capital N as 180 rpm, and the position of the crank, that is crank angle from the inner dead center position, theta is equal to 40 degree. And in the problem it is asked to find out the velocity of the piston as well as acceleration of the piston during the crank position of 40 degree. Okay. So we know that the analytical formula for finding out the velocity of the piston Vp is omega r into sin theta plus sin 2 theta by 2a. So here omega has nothing but the angular velocity of the crank that can be calculated using the formula 2 pi n by 60. Here the engine speed n value has been given in the problem as 180 rpm. So by substituting that in the formula, we can get the value of omega as 18.85 radian per second. Okay. And small n in the formula is the ratio between the length of the connecting rod and the crank length. So 1.5 divided by 0.3, that value can be obtained as 5. So now we can substitute all the known values in the velocity formula. Then we can get the velocity as 4.19 meter per second. Okay. So next, coming to the second part of the problem, that is acceleration of the piston, that can be calculated using this formula omega square r into cos theta plus cos 2 theta by n. So omega and n values have been calculated in the previous step. So just by substituting all the values in the formula, we can get the value of acceleration of the piston as 85.35 meter per second square.